Welcome. So in this video, we're going to do a little DHCP for IPv4. So eventually what we're going to do is add a DHCP server over here, and it's going to provide IPv4 addressing for all of our client devices configured to obtain their IP addressing automatically. And that's whether or not they're on that same network as our DHCP server or another network. We're also going to be turning a few knobs on the switches to make that happen, not just to make it happen, but to make it happen so there aren't any issues with spanning tree and things like that. So let's get started. The one thing that I have done, and you'll notice down here, is I changed the display names down here to all these bottom devices. These are the devices what I have configured to obtain their IP addresses automatically. I'll show you how to do that in a moment. These up here are going to leave as static addresses. Okay, so how we do that, by the way, we just go here, config. Now, normally all you have to do is really click on this tab here, this radio button here, DHCP, for IP configuration. Let's go right here. There we go. We'll make sure for the default gateway as well, but usually if you do one, it should do both. Okay. All right. So if you've done one, it'll do it for the other, but just to make sure I've done it for both there. All right, let me go ahead and close that. So we can verify that these devices did not receive an IPv4 address dynamically. Two ways we can do that. We can either just wander over the device. And when I do that, notice it has the 169.254 address. That's a PIPA address assigned to a device when it fails to obtain an IP address via DHCP. The other way that we can do this is I can just go to desktop, command prompt, IP config, and we can see that it's not even showing the 169 address. Let's do that again. There we go. Packet tracer sometimes does things a little takes a while, or there's a hiccup here and there, but it's a great tool. All right, so let's do this. Let's go ahead and first add a DHCP server. Now, best practice would typically, or common practice, I should say, is to have your DHCP server on a separate IP network or VLAN. Most likely even a separate switch block in our architecture. Maybe you would have a data center switch block just for all of our servers and that sort of thing. Okay, but to kind of keep things simple and also so we can make sure that we understand a few things, I'm going to just go here, add the server, and I'm going to actually just put it right here. Okay, and before I can actually connect it, we're going to configure the server. So I'm going to go here. All right, first thing I'm going to do is add an IP address and all that kind of good stuff. So let me go right here. Okay. I'm going to give the IP address 10.40.0.99. Subnet mask. We'll make it a /16 like everything else. So you can see what I'm doing is I'm adding it to the 10.40.0.0 network, which is also VLAN 40. All right, let's go ahead, and we also need to configure a default gateway. So let's do that, 10.40.0.1. Okay, that's the IP addressing. Next, I'm going to start configuring the DHCP service. Go over here to Services, DHCP. Okay. Now you notice, because I added, let me make that a little wider here. You notice because I added an IP address to the interface, it actually automatically created a DHCP pool for that address. But we don't want to name it that. I can't actually delete this pool, and you can't change the name in Packet Tracer. So what I'm going to do is this. Okay. So what I'm going to do is change the start address. I'm going to just put it in the parking lot for now. We're going to create a pool for that network, but we're going to call it something else. So I'm going to do 210.255.0.0, and I'll put the number of users to 0, maximum users to 0, and I'm just going to click Save. All right, now I'm going to start creating my pools. So the first server pool I'm going to create, I'll just say server pool, and I'll do dash VLAN 10. Okay. Then what I'm going to do is have the default gateway. So this is going to be the server pool for VLAN 10, and our default gateway is 10.10.0.1. Okay. Our DNS server, let's add one, although this doesn't exist. Maybe we'll add one in a later lab here. Okay, starting IP address. Let's go 10. You notice it leaves off from the last pool. That's going to make it easier to add these next ones. I'll show you. So starting address, we're going to make it 10.10.99.1. That way, when I see anything with 10.10.99 in VLAN 10, 1 through, and we're going to make it up to 100 users. Anything I see in that range, I know it was assigned via this DHCP server. Okay, now I don't click add, I don't click save. I click add. So we're going to add that. You see the added that pool. Okay, so now all I need to do is change this, go to 20, 10.20, 10.20. Okay, so VLAN 20, 10.20.0.1 default gateway, 10.20.99.1. Everything else is the same. Add. Okay, I paused there for a second, so you didn't have to watch me do the rest of these, but you can see we have now our 5, this last one we're not using, server pools for VLAN 10, 20, 30, 40. Here's the default gateways for each, same DNS server, similar starting addresses, 99.1 for their subnet, same subnet mask, 100. Okay, we're looking good. Now, there is one more important thing we need to do, and I typically forget this. Turn the service on. There we go. All right. All right, so now we've got our DHCP server. It's not connected to any switch, is it? So let's go ahead, and we're going to connect it to access 2-4 switch. Okay, so let me go there. Move that over. Okay, so the first thing I'm going to do, let me give this command here. We're going to take a look at the current configuration for the port. I'm going to add it to port gigabit 01. Let me paste this in there. So show running config, this little filter, sometimes called a pipe section. If I want to look at just the interface, gigabit 01, I can do it like this, so I don't see the whole running config. Now, just a word of caution, you have to type all of this exactly like it's shown in the running config. It is case sensitive. So if I hit enter there we go. So right now that interface is in the parking lot VLAN. It is switch port mode access. It is shut down. Okay, so let's go ahead and change that. I'm actually going to just copy that in. Let's see, is there anything else I'm missing? No, I'd like to, let me go ahead and just type that in here. Interface gigabit 0/1. I actually, you don't need to do this because we're going to do switch port access VLAN 40, but I like to do it anyway. At least have it in my script or my code when I'm doing it using some kind of program. But anyway, we'll get there another day. I'm going to remove it from there. Okay, I'm going to make sure it's switch port mode access. I'm going to say switch port access VLAN 40 because that's the network it's on. Then, very important, no shutdown. Okay, so we see that now the state is down right now. Okay, it won't be up until we actually connect the server to it. Then we'll see it change to up. That's because it's not receiving any kind of carrier signal or link signal. So let's go ahead and do that. Go ahead and connect it. Go right here. Gigabit 01. Okay, so you can see spanning tree is running right now on it. We've already noticed that all of our devices originally received that a PIPA 169.254 address. Okay, but let's go ahead now and take a look at, let's go to this device here. It's actually a device that's also on these two here. Well, this is a static device, but this device here, this port here is on VLAN 40. Let's go back to that switch and we can verify that. So this here is port 20. So let's do end. And let me just do show run here. Faster. Okay, so that port is on VLAN 40. Okay. Now, previously, it did not get an IP address. Let's take a look now. Okay, so I'm going to go to desktop. Let's go to IP config. Okay, now right now it has this 169.254 address. Okay, so let's do this. IP config /release. And then IP config /renew. Now, by the way, this renew might have to do it a couple of times with Packet Tracer. But notice that it received an address, 1040, there's our 99, and then 2. Okay. So looks like that's working. There's the default gateway, there's the DNS server. All right, so that's great. That works. But how about devices on the other networks? Okay, it worked fine for this device. Okay, it received an address. But how about devices on other networks? Hey, how about this device right here? It's on VLAN 30. Does it receive an IP address dynamically? Let's take a look. What do you think? We do IP config. It's got an PIPA address. Okay, but let's release it and renew it. Okay. Nothing happening. Sometimes it takes a second, but I think it's going to fail. It failed. Let's try it again. It's going to continue failing. Now, why is that? Okay. The reason is that this device is on another network. It's actually on and not just a different VLAN. So because it's on a different VLAN, it's in a different broadcast domain. So when this device sends out its DHCP discover message, which is a Ethernet broadcast, saying, hey, is there any DHCP servers out there? Okay, this server, which is now on VLAN 40, this device is on this port is on VLAN 30. It's not going to receive that DHCP discover message. Okay, so it's on a different VLAN. It's in a different broadcast domain. So we're going to fix that. The way we're going to fix it is by configuring something called DHCP Relay. All right, so let's go ahead and do that. Let's go over to this distribution switch. So this switch here is the default gateway for devices on both the 1030 network and the 1040 network. Okay. So the devices that will get their IP addresses, by the way, let me back up 1 second here. We saw that this device got its address 1040.99.2. You may be wondering, well, what happened to .1? Right here, most likely. There's the .1. Okay, this device is also on VLAN 40. Okay, so when it sent out its broadcast, okay, went out here, oh, VLAN 40 port, no problem. Got tagged, untagged as VLAN 40, untagged VLAN 40, tagged, untagged VLAN 40, tagged, untagged VLAN 40, out all VLAN 40 ports, the server received it. Okay, so these are the two devices so far. But what about these on another VLAN? Okay, that's what we're going to solve now. These devices are on a different broadcast domain, different VLAN. So what we're going to do is we're going to help them out. Okay, so what we're going to do is the default gateway is going to relay, going to help out the DHCP broadcast. So let me go ahead and show you how this is done. Okay, so let me add the command here. First of all, let's take a look at our current interface VLAN 30. That's not what I want to do. Sorry about that. That's the command, show running command section interface VLAN 30. There we go. So this layer 3 switch, it has 2 switch virtual interfaces, one for 1030.0.0 network, this address here, which is the default gateway for that network, that VLAN, and 1040.0.1, the default gateway for the 1040.0.0 network. Okay, so what we're going to do is add something called the IP address command, IP helper address command, excuse me. This command is used on routers and layer 3 switches to enable something called DHCPv4 Relay. This allows DHCP broadcast requests from clients on one network to be forwarded to a DHCP server on another network. Okay, so when the DHCP client sends the broadcast request for an IP address, typically routers don't forward those broadcasts. But by configuring this IP helper address, what it's going to do is the router or layer 3 switch in this case is going to convert that broadcast into a unicast packet, and it's going to forward it specifically to this DHCP server IP address. Okay. So let's go ahead and do that. By the way, in my lab, I have all kinds of information, a lot of detail on it, as a matter of fact. Okay, so let's go ahead and configure this. So I'm going to do config T, interface VLAN 30, IP helper address. Now, what I'm saying is VLAN 30, where I have the default gateway for devices on this network, 1030.0.0, when I receive certain broadcasts they're actually IP broadcasts and Ethernet broadcasts, and also there are UDP segments. And one of them is specifically for ports associated with DHCP. I'm going to forward that to 10, type this in here, 1040.0.99. So I'm going to take those broadcasts and convert them into unicast directly to this DHCP server. I'm going to help you clients along here. I'm the helper address, converting this broadcast into a unicast so it can be sent to the server. Now, for a complete source IP address conversion, what it all looks like, I have it in the lab. In my lab document, which is in the GitHub repository now associated with this playlist, and explains it in detail. Let me hit enter here. Great. All right. Well, let's take a look if anything happens here. Let's go over here to our device right here on VLAN 30 command prompt. Okay. Let's see if it got the IP address. IP config. Okay, it's a PIPA address that it gave itself when it initially wasn't able to reach to talk to a DHCP server. Release. And let's do renew. There we go. Look at this. So it received an IP address from the DHCP server. The DHCP server gave it an address associated with the pool from the request. So the request came from and again, I got this in more detail, but from a device on that network. All right, which happened to be the layer 3 switch in this case. All right, so anyway, we can see that that worked great. Got the IP address, the proper default gateway. Excellent. So actually, if we wanted over, well, it actually probably wanding over is not going to help. Oh, well, we know that one got it. How about this one here? Okay, let's go ahead and do a renew again. There we go. Oh, looks like it already gave itself one, so we were good there. Okay. All right, so we've taken care of this side. Now we don't need the IP helper address for 1040.00 network because these devices, specifically this one here, is on the same network, the same broadcast domain as our DHCP server. But we do need to help out devices over here. So let's go over here and do the same thing. Okay. Okay, I'm going to show the running config first. Show run. Let's take a look at our two VLANs, or at least two of the VLANs, VLAN 10 and VLAN 20. Okay, we can see these are the switch virtual interfaces for VLAN 10 and VLAN 20, the default gateway. These are layer 3. This is the layer 3 switch. Okay, so now let's go ahead and help these DHCP clients out. Config T, interface VLAN 10, IP helper address, same address, 1040.0.99. I'm trying to be careful here. All right, that looks good. Exit. Let's do the next one. Up arrow here, VLAN 20, same IP helper address. There we go. All right. That's all it takes. Now, did these get their addresses? Let's try it. IP config /release, IP config/renew. Now, this one we might have to do more than once. No, it took care of us right away. All right. So there you go. Look at this, VLAN 10. And we know it got it from the DHCP survey because we're using our convention of 99 right here, 99.1 through 100. Okay, right mask, right default gateway, right all that. Okay. Matter of fact, let's do a quick little test here. Let's ping one of our static addresses, 1044.100. 1044.100. Might have to wait for an ARP request here. There we go. All right. Always nice when, after all these years, I can't tell you how many years I've been doing this, and decades. And I still get excited when that ping works. Okay, now we're almost there, but let's take a look at something here. Let's see. Let's talk a little bit about port fast. So what I'm going to do is this. Let's go up to this port here, this switch here. And I'm going to configure a port. Okay, and I'm just going to make it interface FA021. Okay, I'm going to say no switch port access VLAN 255, take it out of there. And I'm going to say switch port, although you don't need to do this, switch port mode access. I always like to be very explicit. Switch port access VLAN 40. That would have overwritten the switch port access VLAN 255. But again, I like to be very specific about what I'm doing. No shutdown. Okay. Okay. Again, this port is in the down state because there's no cable connected. Or if the device was connected and powered off, then same case would be the down state until it detected a carrier signal. Then it would go up into the up state. So let's go ahead and actually do that. Okay, so next, let's add a PC. So I'm going to go over here, PC, and on this PC, what I'm going to do is make sure that we are configured for DHCP. Okay, looking good. Okay, now let's add a cable straight through here. Now I want you to notice the link light on the switch. Make sure I get the right port, 21, amber. Okay, so it's running through the spanning tree states right now. Going to take about 50 seconds before it goes in forwarding state. Meanwhile, the operating system is sending out DHCP discover messages, but they're not being forwarded by the switch because the switch is blocking these right now, not forwarding these frames as it goes through its different states. So this PC, as we can see here, has the 169.254 address. Okay, so this could be an issue. So what we want to do is on this switch port, see now it comes up as green. Okay, well, what we want to do is we want that switch port or any switch ports connected to a single end host and device. We want it to immediately transition to forwarding state so that we don't have an issue with the DHCP messages timing out. Okay, so let's, whoops, sorry about that. So let's go ahead and do this. I've got, again, more information in my lab about this, but about how it will bypass the usual spanning tree states of listening and learning and go immediately into forwarding state. So let's do this. So I am still in fast Ethernet 0/21. Okay, so what I'm going to do right now is I'm going to issue spanning tree. How do you spell tree? There we go, port fast. Now, as soon as I do this, I get a warning message. It says, be careful, Rick. You do not want to be connecting. You've got some old stuff here. Concentrators, bridges. And anyway, I can tell switches are also known as bridges, by the way. Anyway, it says don't connect anything but an end host to this, or you could cause temporary bridging loops, or even worse, permanent bridging loops, broadcast storms. You could cause STP to reconverge, and you might have less than optimal layer 2 forwarding, all kinds of stuff. So what we want to do is we want to make sure that users do not connect a switch to this port. So what I'm going to do is spanning tree BPDU guard enable. Okay, so what that will do is that ensures that if somebody connected a switch to this port, okay, will actually disable the port, error disable the port. Okay. And typically we'd have it go into shutdown mode, so we'd actually have to re-enable the port ourselves. Okay, let's find out what happened first. And that's very important. We don't want users adding switches, because that could violate some spanning tree protocol things like the 7-switch diameter and create havoc in our network. All right, let's do this so you can see what the result of that is. I'm going to remove that link. I'm going to go back here, add the link again. And now notice when I add this link to fast Ethernet 0/21, notice that it immediately transitions to forwarding state. Okay, let's see if our device received an IP address. It looks like it did. There we go. No problem with spanning tree blocking the DHCP discover messages. Okay. Now, this is something that we're going to want to do on all of all of our switches. But before I go there, I'm going to do a little cleanup here. So what I'm going to do, and I'm going to pause this recording, then I'll tell you what I did. Okay, so what I did, just a little cleanup. I deleted the PC. I went back and I went onto that switch port and I put it back into parking lot shutdown. As far as removing the port fast and BPDU guard, typically that's not uncommon to make that part of your default configuration. That's something that we'll talk about that a little later. But when you create your default configuration for a typical access layer switch, it's not uncommon to include spanning tree port fast and spanning tree BPDU guard. Make sure you include them both. Okay, but also put the device in a parking lot VLAN and shut down. All right, we're almost done. The only other thing that we probably want to do here is add those commands to all of our access switches. I'm going to show you how you can do that relatively easy. Okay, so what I'm going to do is copy some commands. So let's just start right here. And what I'm going to do is right at this mode here, I'm just going to paste, and I'll show you what I pasted. All right, so let me move this down so you can see everything I just did. Perhaps, there we go, almost. Okay, so in my script, it just I have config T, and then this interface range. I'm using the interface range command to go into just 2 ports. Fast Ethernet 010 and Fast Ethernet 020. Okay, so since we did the smart thing, and since all 8 of our access layer switches use the same switch ports for their end devices or PCs, that we are going to make all those ports spanning tree port fast and BPDU guard, regardless of whether they are statically enabled IP addresses or using DHCP. Okay, so I'm going to pause here after I go through and do all that on all of my switches. Okay, so I've added that spanning tree BPDU, spanning tree port fast and spanning tree BPDU guard to all these switch ports where I have end devices. Now you may be wondering, Rick, but these are IP phones. I thought you said an IPv phone had a built-in switch. So is that an issue? No. So you can, it's used no problem. Typically, always check documentation, but usually with your IP phone, including spanning tree port fast and spanning tree BPDU guard can be enabled, where you have a port that includes both voice over IP, a voice VLAN, and a user VLAN. Now remember that IP phone we said had a little switch in it. Okay, well, that IP phone with the built-in switch is generally considered safe because the switch in the IP phone is typically a simple layer 2 device that does not participate in spanning tree protocol. I never think of something as a layer 2 switch unless it participates in spanning tree. So this is not a typical layer 2 switch. Okay, does not participate in spanning tree, which means it does not send out spanning tree bridge protocol data units, BPDUs. Okay, so we're not at any risk there of doing port fast or BPDU guard. Since the phone is not sending out spanning tree BPDUs, the switch port here with BPDU guard is not going to error disable the port. Okay, so we're pretty safe there, and our phones these ports will automatically transition to the forwarding state. All right. Well, I think we're all done here. We've seen that we can ping from here to here. So some really good stuff here. All right. In a later lab, in a later video, we'll talk about one of Rick's favorite topics, IPv6. But we'll do IPv6 kind of all together. No different. It's really no different. A little different with dynamic addressing because we can use not only DHCPv4 stateful service, like with DHCP, not only can we use DHCPv6, which is a stateful service for IPv6, similar to DHCPv4 for IPv4, except DHCPv6 server never provides a default gateway. That only comes from the router advertisement. We'll talk about this later. Only comes from the IPv6 router advertisement. Okay, and that where we can also use something called stateless address auto configuration. We'll do that for another video, but I couldn't go through talking about dynamic addressing without including a little blurb there on IPv6. All right, thanks. I hope you enjoyed this lab, this video. I've now created a GitHub repository, so everything all my labs should be there. Have a great day, everybody.